laid upon. The other thing that has to be worried about is that you have to do that profiling as close as possible to the time that the pipeline is going to be laid, because Mother Nature tends to move things around again after you've left. And so you come back in a couple of weeks later and you find there's been a storm or whatever, and what you've taken so much care to flatten out has all of a sudden been moved around again. So you would lose the work that you've done before.
The pipe laying itself is a monstrous job. Once the pipe has been manufactured, it's placed onto supply ships for delivery to the pipe laying barge, the LB200. The barge is longer than 2 football fields, an enormous floating steel welding factory with military precision. There are only 3 of these ships in the world, is using 2 of them here.
Pipeline route has been surveyed before we ever came here. We have an ROV boat that stands by with us. It monitors the pipe as it touches seabed, and it's a predetermined route that we follow.
The barge has been used in the Gulf of Mexico, in the Mediterranean, and off the coast of West Africa. But this is its biggest and most historic assignment. Once the pipe laying process, it can't be stopped, not even for weather or accidents. The pipeline is built as a continuous tube that's dropped from the ship to the seabed. If the ship halts for too long, the strain on the pipe could snap it. The barge moves along at 4 kilometers a day and needs a constant supply of pipe sections, which must be delivered in the order in which they're to be connected and laid down. 100,000 pieces of pipe are laid down end to end in a predetermined pattern.
They get moved by crane 3 or 4 times and go through about 15 or 20 welding stations and coating stations.
The pipe sections are delivered to the assembly floor, deep inside the LB200. Here, the welders are divided into teams. Their job is to create sections of pipe called double joints, each 24 meters long. There's a lot at stake. The pipes have to be put together so there's no chance of leakage, and the assembly line has to keep up a steady pace. The entire operation is monitored by engineers who have video cameras that watch the process both inside and outside the pipe.
It's incredible technology, but the fundamentals are very simple. The fundamental thoughts that go behind it, because it has to be so rugged and it has to work every time, first time, that the actual basic engineering is still fairly simple.
The next stage of the assembly line is to join this short section of pipe to the main pipeline. It's fed out of the back end of the ship and onto the sea floor. It's a complex process that requires a lot of fine-tuning. This is no ordinary welding operation. The process involves a special welding machine with 8 heads per station. Passing through each of the welding stations in 7 minutes, the pipe is then checked by an ultrasound machine. If a flaw is detected, it has to be repaired immediately before moving on to the next station. The process can't be stopped, and the connection has to be perfect, because this is the stage that welds them together forever. The assembly line is manned by industrial workers from over 30 countries. Shifts work around the clock to keep the assembly moving 24 hours a day. Each day, the teams have to assemble 3 to 4 kilometers of pipeline and drop it to the sea floor. After the welding stations have linked the pipe, the final step of the operation is to seal the exposed metal. It's covered in a protective heat-shrunk plastic. Without this, the steel pipe would corrode in the seawater. Then it's time for the most critical step of the operation, offloading the pipe to the sea floor. The section where the pipes are joined is covered in foam to protect the welded joint during the drop. The decks are cleared, and the pipe is ready to be committed to the sea floor. A rubber tensioner grips the pipeline and holds it in place as it slides off the barge. As the pipe enters the ocean, it begins to sag, and pressure is put on the entire pipeline, which is free hanging beneath the ship. Without exactly the right tension, the pipe could snap.
The pipe comes off the back of the barge in what's called a lazy S configuration. So it comes off the back of the barge and trails down to the seabed some distance behind. That S of unsupported pipe has to be kept from just buckling under its own weight. So to keep it under control, you've got to keep that under a huge tension to stop it from just collapsing under its own weight.
As the pipe is lowered, the barge moves forward exactly 24 meters. With this well-oiled operation, the LB200 is able to lay over 100 kilometers of pipeline a month, as long as the pathway is clear. But clearing that pathway is a complicated process. In these particular sections of the pipeline route, a 2-meter deep trench is required. So engineers bring in the massive Saipem plow. This is the PL2. It's being used for trenching in shallower waters. It drops onto the seabed over the 1-meter diameter pipe, where its strong clamps pick it up. Then, as the surface ship pulls it forward, the plow cuts a trench 5 meters wide and 2 meters deep. To fill the trench, the BPL-2 follows behind with backfill to cover the pipe with a protective coating of sand. Early in the design phase, engineers decided to bring the gas from the Ormen Lange field to the processing plant at Nyhamna and then build another 1,200 kilometer pipeline to Britain. At the 600 kilometer mark, the line is broken and connected to the Sleipner riser platform. The Sleipner platform works as a hub, monitoring the 70 million cubic meters of gas flowing into the UK every day. But tying the pipeline to the platform creates a whole new set of engineering headaches. The underwater robots line up the pipeline and the connecting pipes coming from the platform. A massive underwater crane moves them into position. But when they're matched up, there's no technology that can replace human beings in making the final connection. So the welders also have to become divers.
You ready to come down? Your hose good? Okay, he's ready to come down.
Thank you.
The divers move around the worksite in pressurized modules, welding on the sea floor.
Do one lift on it and see if we can rotate it into its proper orientation with you guys. Oh.